Today we're going to be following up on a topic we were looking at on our Sunday Year 7 class, which are angle questions from past JMO papers. In this video we're going to be going over the solutions to the problems we did in class. Consider the following problem. In the rectangle ABCD, M and N are the midpoints of AB and CD respectively. AB has length 2 and AD has length 1. Given that angle ABD equals x, calculate angle DZN in terms of x.
So the first thing we're going to look at is our classic Z angles, where we have two parallel lines and another line intersecting them. As we know, this angle here, we'll call x, is always equal to this angle here. So this is also x. Now if you look closely at our diagram here, you'll notice that these two lengths on the rectangle are parallel, which means that this line, BD, is the same as the intersecting line from before, so this angle, ZDN, has to equal x.
From here, we can draw a straight line from connecting points M and N, which will form a unit square, which means that all the lengths are at 1. As it is a square, we know that all the corners are 90 degrees, and as the line AN cuts across the square, we know that the angle DNZ is going to be 45 degrees.
We know that the sum of all of the angles in a triangle adds up to 180 degrees. So, x plus 45 plus, and we'll just call it question mark like they have, has to equal 180 degrees. So, question mark equals 180 minus 45 minus x, which is equal to 135 minus x.
Now consider this problem. ABCD is a square. The point E is outside of the square, so that CDE is an equilateral triangle. Find the angle BED.
The question wants us to find angle BED, which is this angle here. The first thing we know is that ABCD is a square, which means that angle BCD is going to be 90 degrees. We also know that triangle CDE is equilateral, so we know that angle DCE is equal to 60 degrees, which I'm going to write in here with red pen. 60 degrees.
Since CD is one of the sides of an equilateral triangle, we know that CE is the same length of CD. And since CD is also part of a perfect square, we know that the length of CD is the same as the length of CB, which makes that triangle BEC isosceles.
Since this triangle is isosceles, we know that this angle and this angle are the same. So, we can calculate what they are. We know that angle DCB is 90, and we also know DCE is 60. So we know that the overall angle here is going to be 90 plus 60, which is 150 degrees. And since we know that the angles in a triangle add up to 180, we know that CEB plus CBE plus BCE has to equal 180. So CEB plus CBE equals 180 minus BCE DE, which we know from before is 150 degrees, so 180 minus 150, which is equal to 30. And since these two are the same, we know that they're both equal to 30 divided by 2, which is 15. So now what we're going to do is we're going to say that both of these blue angles are equal to 15.
The final step of this problem is, as it's an equilateral triangle, to minus 15 from 60, as all angles in an equilateral triangle equal 60 degrees, which will give us 45 degrees as the angle at DEB.